Okay, we're going to be looking at the 3.3 practice quiz, which is actually on paper. You should have gotten it in class today. Looks like this. And I'm going to kind of work through it fairly quickly. Not a lot to this one. Really straightforward math on this quiz. You're going to see a very similar set of problems tomorrow. So I'm actually going to go back and forth because I'm not sure there's enough room to work on this paper and it kind of stifles me. So we're going to go back and forth between this actual paper and some white paper. Okay. So if I look at this first problem, x minus 10 equals negative 6. So basically all this question here is asking is what number can I subtract 10 from and get negative 6? Okay. So if you're not mine and you're watching this, I always draw this vertical bar to help me kind of organize my equations, think about what's the left side and what's the right side. So if I'm trying to get the x all by itself on the left side, that means I need to get rid of this minus 10 right here. And if I want to get rid of minus 10, I can add 10. And minus 10 plus 10, that goes to 0. Remember, always check to make sure that you actually go to 0, leaving me with 1x on the left side of the equal sign and negative 6 plus 10, which is 4 on the right side. And remember that you can check this pretty easily just by plugging 4 in. So I'd be asking myself, does 4 minus 10 actually equal negative 6? And of course the answer is yes. You can use a calculator if you need to. All right, looking at question number 2. Same type of question, different operation. So the question is 6 times what number would give me 24? You can probably do this one in your head, but remember in this class we always show quality work, so I need to know why things happen the way they happen. So I want to make the coefficient that invisible 1, right? So in order to make the invisible 1, I'm going to divide by 6 on both sides because 6 divided by 6 is 1. And that leaves me with 1x is equal to 24 divided by 6, which is 4 again. And I can plug it back in just to check. 6 times 4 is 24. Yep, I'm happy with that. Number 3 is 5x over 3 equals 10, which I might also think about as 5/3 x equals 10. These are actually the same exact thing out in the front or up in the numerator. Now, if it's in the denominator, totally different thing. But in the numerator or out front, same exact thing. Okay? So remember with this, we multiply by the reciprocal. We multiply by the reciprocal. And we multiply by the reciprocal because it's going to create our invisible 1. So I'm going to go ahead and show you that that happens. So 3 times 5 is 15, and 5 times 3 is 15x, right? And then if I want to multiply on this side, I think about this 10 being over 1. And 10 times 3 is 30. 1 times 5 is 5. And then I simplify the fractions. So 15 divided by 15 is 1x, or just x, and I don't need to write the invisible 1. So that's why that reciprocal works every time, because it's going to create 1. And then 30 divided by 5 is 6. And if I wanted to check that, I might use a calculator on this one, right? So I'd be checking 5x over 3 equals 10. 5x over 3 equals 10. Let's see if we can see this. Yep. So we're going to do control divide. 5 times, what did I say the answer was? I've forgotten. 6. 5 times 6 over 3 and hit enter. And my answer is 10. And that's what it should be equal to here. So yes, indeed it is. So my answer is correct. Okay. All right, moving on to question number 4. And I'm going to write on this paper. Question number 4 says 3x minus 4 plus 2x equals 15 minus 4x. Okay. So again, with my organization, first thing I'm going to do is look for like terms. So I'm going to take 3x and add 2x. 3x plus 2x is 5x minus 4 equals 15 minus 4x, right? And then I'm like, hey, I don't want x's on both sides. And because I don't want x's on both sides, I need to get rid of it from one of the sides. So I'm going to remove this one. It says minus 4x, so if I want to make this go away, I'm going to add 4x, right? Because negative 4x and positive 4x is 0 like it needs to be. So that gives me 9x minus 4 equals 15. And now it's a simple little two-step equation. So I'm going to add 4, making that 0 like I need for it to be. Remember, I'm moving anything added or subtracted first and removing anything that's attached with multiplication or division second. So I have 9x is equal to 19, and then divide by 9. And guys, I don't care if you want to leave the answer as 19/9. I'm perfectly content with you doing that. Okay, I'm going to zoom out so you can see that whole problem at once. This right here is quality work. I showed every single step, where things came from, how they made it the way they made it. I'd love to see this on your quiz tomorrow. All right, moving on to number 5. Number 5 is 5 times x minus 2 is equal to 6 minus 3x. A little organizing line here. This time I don't need to combine like terms, but I do have a distributive property here that I need to deal with. So I'm going to multiply. 5 times x, that's 5x. 5 times negative 2, that's minus 10. Leaving the right side alone for now. And again, I'm in a quandary about the fact that I have x on both sides of this equation, and I just want it to be x equals, right? I don't want x on both sides. I just want x equals. So I'm going to get rid of this minus 3x over here, and I'm going to do that with addition. So I'm going to add 3x to both sides. 5x plus 3x is 8x, bringing down the minus 10 and the 6. Negative 3x and positive 3x, that really does go to 0, so I'm happy with that. Again, I'm always checking to make sure that I actually created that 0 to get rid of that term. Then I find x, look for anything added or subtracted, get rid of it, right? Add 10 to both sides. Adding 10 because negative 10 and positive 10 together make 0, so that's what makes it go away. So I have 8x equals 6 plus 10, which is 16. And then I have multiplication here between the 8 and the x. So I divide by 8. And x is 16 divided by 8, which is 2. Okay? Moving on to question number 6. Question number 6 says 2 minus 3 times x plus 1 is equal to 6. So the first thing I'm going to do is distributive property. If there's a parentheses in the problem, I always want to start with distributive property. So I'm going to go ahead and distribute the negative 3 to the x and the 1. The 2 doesn't get to play because it's not in the parentheses, okay? So it's just coming down. Negative 3 times x is negative 3x. Negative 3 times 1 is negative 3. Once I do distributive property, I'm going to double check to make sure that I don't have like terms. And I, in fact, do have like terms. So I'm going to combine 2 minus 3. I'm going to combine 2 minus 3. So I'm going to have negative 3x minus 1 because 2 minus 3 is negative 1. Once I've combined like terms, then I'm going to find the x and anything added or subtracted to it and get rid of that. So I'm going to get rid of minus 1 by adding 1 to both sides. Again, checking to make sure that I actually created the 0 that I wanted to create. Negative 1 plus 1 is 0, so it's gone. And I have negative 3x is equal to 6 plus 1, which is 7. Getting rid of times negative 3 by dividing by negative 3. And we end up with x equals negative 7/3. Moving on to number 7. We have 5 times 2x minus 4 is equal to 1 plus 6x. Distribute, distribute. Right? So we have a parentheses. If we have a parentheses, we always start there. 5 times 2x is 10x. 5 times negative 4 is negative 20. So 10x minus 20 is equal to 1 plus 6x. I have x on both sides. I don't want that. So I'm going to get rid of it on one side. It really doesn't matter which side you choose. I usually choose the right side because you guys like variables on the left. So I'm going to get rid of this plus 6x by subtracting 6x. Right? 6x minus 6x goes to 0 like I need it to. And this becomes 4x minus 20 is equal to 1. Find the variable, find anything added or subtracted to it, get rid of it. So negative 20 and positive 20 come together to make 0 like I need it to, leaving me with 4x on the left side. 1 plus 20 is 21 on the right side. Divide by 4, and x is equal to, and I'm just going to leave it as 21/4. If you want to go to a decimal, go crazy, but I'm just going to leave it as 21/4. All right, one more in this section, number 8. Number 8, we have 8 plus 3x minus 16 equals 14. 8 plus 3x minus 16 equals 14. So no distributive property this time, but I do see some like terms I can combine. So 8 minus 16 is negative 8. Kind of an easy one here for this last one. Find the variable, find anything added or subtracted, get rid of it. 14 and 8 makes 22. And then divide by 3 and get an answer. Okay? All right, I'm sorry, my nose is bothering me. So, moving on. This feels dry, I apologize. We're looking at answer the following based on the graph. So we're looking at this quadrilateral. Quadrilateral is just a 4-sided figure. And I'm asking you some questions about it. First question that I'm asking you about this picture is, what's the distance between A and C? What's the distance between A and C? Here's A. Maybe I get a highlighter here. Here's A. Here's C. Because it's not perfectly vertical from A to C, I can't just count it, right? I need a distance formula. And so what I'm going to do is I'm going to figure out, okay, what's A? A is the point 1, 5. And what's C? C is the point 0, negative 2. I'm sorry about this line in the middle of my paper. I don't know why that happened. So C is 0, negative 2. It's on the axis. A little hard to see because of that random line in the middle of my paper. And we need a formula, right? You should see the word distance, immediately think, oh, I have a formula for that. Distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. And so I can literally just plug in. So here's my x1, and here's my x2, and here's my y1, and here's my y2. So the distance is going to be the square root of 0 minus 1 squared plus negative 2 minus 5 squared. And you can actually, I don't mind, go straight to decimals. Okay, go straight to decimals. So we're going to have the square root of 0 minus 1 squared plus what was it? Negative 2 minus 5 squared. Make sure you're using your parentheses because that's going to make a huge difference for these problems. We end up with 7.07. And I might just look at my picture. I mean, if it were straight down, it would be 1, 2, 3, 4, 5, 6, 7, right? So we would expect for this distance right here to be a little more than 7 because it's not straight down. I need to zoom out so you can see everything I'm doing here. So the 7 makes sense, right? The 7 makes sense is my point. All right, if I want to talk about the midpoint, between B and C, the midpoint between B and C, we've only talked about this about 456 times this year. The midpoint formula is the sum of the x's divided by 2 and the sum of the y's divided by 2. So I probably need to know what they are. So B is the point, looks like 6, 1. And C is the point 1, negative 2. So here's my x1, here's my x2, here's my y1, here's my y2. So if I want the midpoint, I'm going to add my x's together. I will in a minute. So that would be 6 plus 1 over 2. And I'm going to add my y's together. 1 plus negative 2 over 2. And that's going to give me my midpoint, which is going to be 7 halves, and looks like negative 1 half. Or if you don't like fractions, that looks like 3.5 and negative 0.5. I'm just going to double check that really quick. So I want to make sure that it's on the midpoint of BC. So I'm going to go 1, 2, 3 and halfway, and then down a half, and make sure that I'm actually on the midpoint. And to me, it looks wrong. It looks a little bit wrong. And so I'm wondering what I did. Oh, I know exactly what I did. Look at this. I'm losing my mind, and I said this point C, which I previously wrote as 0, negative 2, as 1, negative 2, because I'm crazy. So let me just adjust here. That happens. But guys, this is why we check, right? Because I want to make sure it does make sense. So this should have been, instead of 6 plus 1, this should have been 6 plus 0. So this should have been 6 over 2, which would not be 3.5, but rather just 3. So let's see if that looks like it's more in the middle now. So 1, 2, 3, and then down a half. Yeah, that's better. It's actually on the line this time. Looks like half. Another way I could think about that is it's 1, 2, 3, 4, 5, 6 across. So halfway would be 3. And 1, 2, 3 up. So half would be that negative half place, right? So that'd be another way to think about that midpoint. All right, slope. Slope has its own formula too. We have y2 minus y1 over x2 minus x1. And we want the slope of DC, so we know it's going to be negative. So D is, here's 0, 0, negative 2, 2. And I'm not going to mess this up again. C is at 0, negative 2. Here's x1, here's x2, here's y1, here's y2. So if I want the slope, which we call m, we do y2 minus y1. So negative 2 minus 2 over x2 minus x1. So 0 minus negative 2. 0 minus negative 2 becomes 0 plus 2. And so I end up with negative 4 in the numerator and positive 2 in the denominator. And when I divide, I end up with negative 2. So there's my slope. So it's the distance, right? There's a midpoint. There's a slope. Now I want the missing endpoint, right? So I've got a couple of ways I can think about this. I can do this intuitively. So I'm saying A is the middle, B is an end, right? So the other one's going to be up here. So I go up 1, 2, 3, 4. I go over 1, 2, 3, 4, 5. So to get the other endpoint, I go up 1, 2, 3, 4. I go over 1, 2, 3, 4, 5, right? So my endpoint's going to be here. And my whole line segment would look like this. Wow, I can't draw a straight line to save my life. The whole line segment would look like this with A in the middle. And we're wanting to know, what's this guy? Okay? And you probably can count it and know. Well, we talked about two methods to do this, right? So midpoint A is at 1, 5. Here's the middle. Endpoint B is at 6, 1. So we can do the counting method. We can say, okay, to get from 6 to 1, I had to go down 5. So to get to the next endpoint, I need to go down 5 again. Now down on the x's is actually left, right? Can you imagine that? So if I go down from 1, 5, 1, 2, 3, 4, 5, I'm at negative 4. And then for my y's, I go from 1 to 5. You can see this. I go up. 1, 2, 3, 4. I go up 4. Then I got to go up 4 again from 5, and now I'm at 9. So here's my endpoint. But some people don't like that intuitive method, and so you have an algebra method using the midpoint formula. Okay? And so that looks something like this. I have an endpoint at B that is 6, 1. Okay, let's call it x1 and y1. I have a midpoint at A at 1, 5. Let's call it x sub m and y sub m for midpoint. I have a formula that finds me the x part of the midpoint. It says x1 plus x2 over 2 equals the x part of the midpoint. Let's call it x sub m. And the y's. y1 plus y2 over 2 equals y sub m. Now let's plug in what we know. We know x1. We don't know x2. And we know x sub m. We know y1 is 1. We don't know y sub 2. And we know y sub m is 5. Well, now I just have two-step equations that need to be solved. So I can take this whole guy and multiply it times 2, and this whole guy and multiply it times 2. Right? 2 divided by 2, that goes to 1, and it leaves me with 6 plus x sub 2 equals 2 times 1, which is 2. And then just subtract 2 from both sides, and you get x sub 2, where the other x is 2 minus 6, which is negative 4, which we found using the other method. Right? So here's that negative 4 from the other method. And then we suspect we're going to get 9 on this one, right? We just saw that. So we're going to multiply both sides times 2 times 2. 2 divided by 2, that goes to 1. I have 1 plus y sub 2 equals 2 times 5, which is 10. Then I solve my y by subtracting 1, and I get y sub 2 is equal to 9. And so my midpoint, my endpoint is negative 4, 9. And this is the other method we talked about. So you can either solve for it with algebra, or you can count. It does not matter to me which method you use. Okay, guys. Good luck on the quiz tomorrow. I hope you found this to be helpful.